Hi and welcome back to ShoutingElectronics. We got two patients on the workbench today. Actually, I've got a third one somewhere floating in the back of my van. I can't find it at the moment. These are battery backup power supplies. Now, with all the recent load shedding, power on and off, people running on unstable generators and that, so far I've had 3 of these die in the past couple of weeks. So let's just take you through this one, because this one's mostly intact still. Okay, yes, there's a bit of moisture on the battery. That's not battery fluid. Okay, if you can look in the back there, we've got our switch mode power supply. That converts our 230, 250, whatever our voltage is, down to 12 volts. 14.2 volts DC it says. Which runs into this little circuit board, and the circuit board ties into the battery. Just take you a bit closer in on this board. Okay, now this board has a buzzer, a relay, a 1 amp fuse, and it's got a couple of diodes and a little chip on there. Okay, so this is basically a battery charger. Now I lost my screwdriver. Okay, so this circuit actually allows the battery to charge. Let me zoom back out again. It allows the battery to charge. When the AC fails, the LED changes color there to say that you are running on battery mode. When the battery starts to get too low, the light turns red, and when the battery gets to a certain cutoff threshold, the relay opens and the light turns off to protect your battery from deep discharging. The terminals here, you've got a AC fail output that normally connects up to your alarm transmitter so that it can transmit a signal saying that AC has failed. You've got a 12 volts, a negative, and a 12 volts and a negative, just parallel outputs. And you've got a nice fuse here. This power supply is rated at 3.2 amps. So your load, as well as charging the battery, has a limit of 3.2 amps. Anything more than that should shut down this thermal fuse. Okay, now, like I say, I've had a few of them die recently. So we got this one here. I've got this one, that the switch mode power supply for it is lying somewhere in the back of the van. This one, this is the switch mode power supply for another one that's also gone faulty, but once I've put it together, I can put it together with this if I can get it working, and that one will be complete. And then this I pulled out of another box that's still at a customer's place. I didn't want to remove the box and leave an ugly unpainted section on their wall. But this is also the same, also 3.2 amps. This one's nice, it's got a removable fuse, but it's also an open frame, so more chance you shock yourself. This one actually looks like it's got a little splatter inside it. Okay, looking at the casing here, we've got some charring. Oh, I see a problem. Straight away, I see a nice puffed up capacitor. Let's see if you can see that there. You can see that lid is domed. It's supposed to normally be flat, and the fuse is pretty much destroyed there. This little cover stopped it from sending glass shards all over. The fuse definitely shorted, and you can see a lot of splattering from the capacitor over there. So this one I would be very suspect. I'm going to have to check the diodes, obviously replace the capacitor, check that the transistor's okay and that, and then change the fuse. So this one's definitely dropping little pieces of glass all over the show. Okay, this one that I took apart the other day, not on camera. I think it's not giving any output. The fuse test's okay. Capacitor looks fine, but I'm not getting any output, so we'll take a look at that as well. Let's try a watch screwdriver on this. Okay, let's take out the battery. This isn't the battery it normally comes with, it was just a battery for testing purposes. Unhook the mains. This one as well. Same thing, capacitor has blown its magic juice out. Splattered nicely there by the capacitor, so we know the capacitor definitely had it. Fuse is also in 1,000,000 pieces. Transformer's got some dirt on it. So I think whatever we find wrong with this one is going to be the same that we're going to find wrong with this one. Then that one's just being silly by itself. So let's clear some space, take these capacitors out the way. Let's see what we got. See if this one's any better. I've still got it in a shot there. Switchmode power supplies. When they go boom, they go boom. Okay. I don't we just love black solder mask. Okay, so let us get rid of this capacitor, because we know that's faulty. Okay, so that's out, and if we look, it's a Chong. Whoa, focus. It's a Chong A, 40 to 105 degree, well, minus 40 to 105, 47 mic, 400 volts. Let's see if I've got one of those. I have to find something that's got one on it, but let's just check anyway. Dead short on the capacitor terminals. I'm now testing across the diodes there. It's supposed to show me about 0.5. It's supposed to be showing me 0.5 or 500 or something on the one side, and it's showing me a dead short. It's a short across the transistor, it looks like it. 8N60 transistor. Yeah. Dead short across the transistor. So this is going to need a capacitor, the diodes should be changed, the transistor and the fuse should be changed. So I expect this other one... Oh, wait a minute, these three are designed exactly the same. This is just through hole and this is surface mount and surface mount. They look almost identical. Okay, well there's a few surface mount parts here. So obviously that has been designed the same. Let's check this one's here. This one's here. That doesn't sound like proper English, but that's what happens when you're tired. Okay, we've got no short on this one. So do you guys think there's any chance of resurrecting this one easier than those ones? If I check across one of these diodes, here's 0.5 in the other direction. Open circuit, so the diodes seem okay on this thing. Let's hook it up to power. And watch, it just wants to be mean and start working today. Are you gonna go bang? Okay, so you see no green indicator light glowing there. It's right next to that potentiometer. Let's go to 20 volts DC. And we are getting no DC. 500 volts AC on the tester. We're going to test across the capacitor. Oh, sorry, it's supposed to be 500 DC. Okay, 349 volts, so that is fine. Okay, so we're getting input. Okay, I wonder if this switch mode chip is happy. Maybe it's toasted. GR8836. GR8836 is a highly integrated low startup current PWM controller. Ground out VCC. Okay, so let's see what the VCC is. 5. VCC is supposed to be 30 volts. Okay, so let's see if the chip's getting power. Okay, it's supposed to be 30 volts DC. Ground is 8. VCC is 2. So I am getting no supply voltage to the switch mode controller. Okay, so pin 2 runs through this 155 resistor, and I'm not getting anything out there. So let's do this. Let's go to our pin 8. Nothing on that side. Oh, there we go, 356. So we're getting power on this side of the resistor. We're not getting power on that side. Okay, let's unplug it. So we need 1.5 mega ohms. Okay, now I was going through my little resistor collection here, my SMD resistors, and then I thought, wait a minute, I've got these boards, they're all similar, maybe they use the same resistor. And they do. 155, 1.5 meg. There you go. Like my tweezers. Yes, it is unplugged. I'm not going to do a reflow soldering job here. I'm just going to do a piece by piece. One, 5, 5. That little just over there, mustn't lose the good one. Okay, so just heat up both sides quickly. And fling it across the bookshop because we don't need that one anymore. And find some of my solder wick. Solder braid, solder wick. Okay, there we go. Okay, there we go. So now we're going to just put a bit of solder down there. Take our 1.5 meg resistor. Very carefully. And very slowly. Okay, so that's should bring power back to the switch mode controller chip. Okay, let's see. Put 2.5 megs over there. Check there is. This one says shorted there, that's right. That's right. Okay, so let's check pin 2. So pin 2 and pin 8. Checking it on this. It's also on the board, 500 volts. Pin 8. Okay, so we still have power on this side of the resistor. Nothing on that side. So there's something shunting that resistor, that current down. Unplug you. See what those two are. That's a capacitor. Tin mic cap. Across the tin mic cap. 11 ohms. Okay. Pull our tin mic cap out. Okay, cap looks fine. 10 ohms. Okay, so with that capacitor out, we're still getting about 10 ohms across there. So let's pull switch mode control IC out. Okay, so switch mode IC is out, capacitor is out, and the resistance across there is now infinite. So does that mean our switch mode IC is faulty? Well, that's one way to find that out, and that's to borrow another switch mode IC from the same board I just pinched that resistor off. Okay, so I've replaced the capacitor. When I put it back in, I've replaced the switch mode IC with the one that we got from the other power supply. I hope that's good still. Let's plug it in, and hopefully it doesn't go boom. Ah, here we go. It didn't go boom. That's surprising. And if we look closely there, we can see I've got a green light. No, I can't look too close. My camera doesn't like looking closely. Let's check. Volts DC. Okay. Zoom you out of it. Okay, volts DC. Output 15.16 volts. We want to go about 13.8 volts to float charge the battery. So we have to use a screwdriver that doesn't adjust the pot. And we'll try another screwdriver that doesn't want to adjust the pot. Why not? Okay, let's just trim it up a bit. Or down a bit, I don't know which way it is. 15.34. 15.88, nope, that's a bit too high. Let's take it right to the end stop there. 14.9. 14.9 is a bit of a problem. It's 1 volt higher. Poor battery's going to be toasted. Okay, so for some reason it's kicking out a higher voltage than it's supposed to be set to. So let me just figure this out. I'll be back now. Okay, so the built-in feedback through the opto isolator over there, going back to the main switch mode chip, it just didn't want to work out right. So what I did here is in series with the potentiometer. Whoopsie, there we go. Don't know if this is going to focus. Okay, in series with the potentiometer, I put a 1.5k resistor, which matches this 1k potentiometer. And now let's see what... I did break the track there in order to put that resistor in series with the potentiometer. So let's go, let's switch it on. We set to our minimum, sorry, yeah, we set to our minimum voltage, our lowest voltage. Okay, so 13.67 volts, 13.68 roundabout. let's crank it up to our maximum voltage. I wish I could find my proper trimmer. Screwdriver. Okay, so that goes from 13 point something up to 14.5, which is fine because if you look at this control board here, it wants a 14.2 volts input. So let's go to 14.2. Before we were at 14.9, which might have been a bit high for it. 14.22, 23. That's fine. So just by putting a resistor in series with that potentiometer, you can lower your minimum voltage. Put a resistor in parallel, and you might be able to increase your maximum voltage. But I wouldn't try that because you don't know. You might stress. It depends what those capacitors are rated for. Now let me put this back into its casing, put it back into the box, connect it up to the control board, and we'll see you in a bit. Okay, so it's all together now. Got my battery hooked up. And let's power it up. And it beeps. And I don't know if you can see that. Got a flashing red light there. What does that mean? Let's check our input voltage is 14.01. 13.5 battery voltage, and our power output is 13.3 volts. Got a battery charging light there. So I think it's good. Don't know what a flashing light means, but anyway. I'll just nudge it up a tiny bit more. Maybe it means the battery is flat, because the battery hasn't been charged since the thing went faulty. Okay, let's... Obviously it wants 14.2 volts under load. 14.28. Okay, so now if we fail the mains, got no more battery charge, or battery charge is still flashing, and there we've got a AC fail output, and we've got no light on. Do I have the wrong case here? Okay, turns out that wasn't the right board for this case, so now I've got the right board in. As you can see, we've got a green LED because we are charging, and if I switch off, it takes a bit of a while, and then it changes to orange to say we're discharging and we're running on the battery. So that's a success. Gonna just run for a day or two, and then go put it back in. At least we got one working out of all three. That's plus. If you enjoyed this video, please give it a thumbs up, subscribe to my channel, and click the little bell icon if you want to be notified whenever I upload a new video. Thank you.